Hello students, this is our in-class work that we did in the last class, and most of you did good in some part and fail in some small things, which make me happy because I can see that you really know what you're doing, but some of you still have questions, so I decided to record this video and do step by step. I'm sorry, my voice is still bad, but I think you can hear me. So here is asking us about the significant figures, and you need to remember the rules. So, and this over here, I'm sorry, this over here, 108,700 kiloseconds, we have 1, 2, 3, 4 significant figures. And why you don't take in consideration this? Because we don't have a decimal point. So if you don't have a decimal point, you don't count the zeros after the non-zero numbers. So they will be not significant. So we have 4 significant figures. And here, those are leading zeros. So the leading zeros are not accounted even if you have the decimal point over here. The only zeros that you're going to count is the zeros after non-zero numbers. Okay? So here we have 1, 2, 3, 4. So we have 4 significant figures. Good? And here, so that is a conversion. So that is exact number. So you cannot change that. Okay? There is no way that you're going to say that 1 inch will be 2.55 centimeters or 2.60 something. No, you cannot change that. So that is exact number. So that is an infinite conversion factor. So infinite conversion factor. Okay, the same thing will happen with the coins, for example. If you have a coins, 50 coins, okay? So if you have a 50 coins, you have 50 coins for 50 persons, 50 people. You cannot change that, or you don't have 50 and half students inside of my class. You can have 50. Okay, so that is an exact number, so it's an infinite conversion factor, so you don't count the significant figures over here. Okay, so let's go to the next one. We talked about this accuracy and precision. Remember, to be accurate, you need to have values that is your target value. Okay, like here, the actual value for the density of sugar solution is 1.75 grams per milliliter. Okay? So, but a student performs an experiment to determine the density of sugar and got 1.11, 1.81, 1.95, and 1.75. So the values that she got is completely different from each other. Like this is completely different from 1.11 is different from 1.81. It's far away from each other. So there is no precision over here. Okay? Not precise. And why it's not precise? Because the individual data points vary from each other. So the individual data points vary from each other, right? They are different, so there is no precision over here, so not precise. And it's accurate. No, it's not accurate because the value that I want is 1.75. Look at this, 1.11, 1.81, 1.95. The only one that I have is 1.7. And if you do the average, look, the average, which will be the sum of all and divide by the number of sample. So we have 1, 2, 3, 4. So you're gonna have 1.66 grams per milliliter, okay? Which is not close to this value over here, 1.66 and 1.75. So calculate the average, okay? It's easy. Just add all together and just double check if I have the correct value. So I'm using my calculator. So 95 plus 1.75. So then we divide by 4. Yeah. So you're gonna have this, okay? So if you add all together, so 1.1 plus 1.81 plus 1.95 plus 1.75 divided by 4, so you're gonna have 1.656, okay? I round because this is the number of digits I have, significant figures, 2 significant figures, so I round that, okay? So it's not precise and not accurate. So our answer will be D over here, okay? So multiple choice did like I did over here, so you don't do like just choosing your, answer, just not pick the answers. Try to do it by yourself and then you check the answers. Let's go to this measurement over here. So we have a ruler over here in centimeters and we have a metal over there. So you want to know the value. Remember, this ruler, look at this. I can say that I have 15.1, 15.2, 15.3, 15.4. But if the measurement is between those small lines over here, I can still, right, give it another digit number. So 15.15, 15.05 if it is between this line over here and this line over here. So it'll be 15.05. We can always predict the next digit. So here I can say that it's exactly 15, so it will be 15.00 centimeter. Okay, this is my point of view. But imagine if a student thought, no, I think it actually is in here is between 9, 14.9 and 15. So I can say it's 14.95 centimeter. This is okay as well, okay? So they're both okay. And another student said, no, I think the measurement should be over here and it's between 15.00 and 15.10. So gonna be 15.1, sorry, 15.05 because it's not 15 and it's not 15.1. So gonna be 15.05 centimeter. It's also okay. So, okay, I said that it's 15 centimeters. I rounded. It's wrong. Okay? So, you cannot say that it's 15 exactly. So, you need to tell me the digits over here. Okay? You need to tell me the certainty as well. Okay? So, this is how you're going to measure. Remember, a question about this can be in the test. And if you forget the unit, you got half question. If you don't use the digits, it's 0. Okay, it's not right. Doesn't matter if you did it right or wrong. If you said like 15, okay, I say 15 over here, but this is not the measurement. 15.00. Okay. Let's go to number 4. Number 4 is also about significant figure like in the first question. But here we have a map. So let's remember like just a kind reminder here. When you have addition and subtraction, we need to look to the smallest number of digits, right? And if you have multiplication and division, you must look to the smallest number of significant figure. Okay, we have a mix over here. We have a subtraction and we have a division. So first, I'm gonna do this subtraction over here. And if you do the subtraction, you're gonna have, let me just use my calculator here because I want exact numbers. So 548.4 minus 49.71. This is 9869. However, let's grab another pen. The smallest number of digits is over here, right? One digit. So my result should have only this digit over here. Okay, so I have a three significant figure. However, I will not cut the number right now. I will not round it right now because I didn't finish my calculations. But I know up here I have three significant figures, okay? So I have 47.27 minutes. I have meters over here. So now I will divide this and I'm gonna have 2.0877935, all the numbers. But look at this. Here I have three significant figures, and here I have four significant figures. So the smallest is 3. So my final result must have 3. Don't forget the unit, okay? So 3 will be 1, 2, 3. So I need to stop over here, right? So my final result will be 2 point, since this is bigger than 5, it's bigger than 5, so I will increase 1 over here, so it will be 2.09 meters per minute. Okay, got it? So you need to know how many significant figures you have in the first equation, but you cannot round here because you didn't finish your math calculations. So you need to know the significant figures that you have, because actually you only gonna have 3, because that is the number of significant figures that you're gonna have in this math over here, okay? So at the end, you're gonna compare which one is the smallest number of significant figure and get the smallest number, which is 3. So then you got the result, okay? Good. So let's go to conversions. So liquid nitrogen, which has a freezing point of negative 210 Celsius degree, is often used to remove awards and to treat precancerous skin lesions. Convert this temperature in Kelvin. So to convert in Kelvin, we know the temperature in Kelvin will be temperature in Celsius degree plus 273.15. Look, this is the exact number. This is a formula, okay? So you cannot change. So we don't count significant figures over here. We count over here, okay? So if you don't pay attention to this, you're gonna make mistakes. So pay attention when you have formulas. You have exact numbers. If you have conversions like 1 centimeters, it's equal 10 negative 2 meters. So you are saying exact numbers, so you cannot change them, okay? So now what I'm gonna do is I have negative 210 Celsius degree plus 273. So here, 0.50. Look at this. I only have two significant figures over here, and here I have 5. So my final result must have two significant figures. So 63.15, 63 kelvins. So we're gonna have only two significant figures. So since this is smaller than 5, my final result will be 63 Kelvin. Okay? Okay. If I don't ask you to pay attention to significant figures on the test, still you're gonna pay attention to significant figures, because from now your result must always take into consideration the correct number of significant figures. Yesterday, on the last class, I'm sorry, that we did this work in class, I said that I would not take point in the temperature conversion because we just talk about that in class, and some students got confused about exact numbers in the formula and exact numbers in the temperature. Okay, so the only number that you have exact numbers is the numbers that you have in formulas, like 273.15, or like here that they give us the Fahrenheit and ask us in Celsius. So if you went to your PowerPoint to check the formulas, what you have is this. Let me just put this up a little bit. Okay, so what you have is this. So I have temperature in Fahrenheit will be temperature in Celsius times 9 divided by 5 plus 32. Those two numbers here are also exact numbers, okay? Like this 273.15. So we don't count the significant figures over here, okay? Just the temperature that it gave to us, we take into consideration, okay? So if you want the temperature in Celsius, so what I'm going to do is isolate this. So what I'm going to have is temperature in Fahrenheit minus 32, right? Multiplied by 5 divided by 9. That is the formula that I'm going to use. So you can put the numbers over here if you want, if you feel better, organize your math over here. So now I will just plug in my results, my data is what I have. So I have 94.4 minus 32 times 5 divided by 9. So my temperature over here, so see here in this equation, I need to look to the decimals. And this is exact number, so I don't count this, but here I have one decimal. Right? So I have a 62.4 times 5 divided by 9. So my temperature in Celsius will be this 34.666. So I have just, one decimal over here. So we're going to stop over here. And since this is bigger than 5, so I increase 1 over here. And my final result will be 34.7 Celsius degree. Good? Okay, so last one. I will now do the bonus because you're going to find the bonus question and a separate video, ibuprofen, okay? If your pace on the treadmill is 65 meters per minute, how many seconds will it take for you to walk a distance of 5,555 feet? So, how are you going to do this? You know that you can do 65 meters per minute. Now you need to feet. So if you went to the internet, because I asked you to Google, because I couldn't provide you, you know that 1 feet is equal 12 inches, and also you know that 1 inch, um, sorry, 1 meter is equal 39 inches, right? Okay, that is the conversion I have over here. Okay, so what I'm gonna do is say we'll take for you seconds. They ask seconds. I have minutes. You know that 1 minute is 60 seconds. Okay, so I wanna walk 5,555 feet, and I wanna convert this in meters. So what I have here is 1 feet is 12 inches, and 39 inches as 1 meter. So I'm gonna convert in meters because I can cut this feet over here and I can cut out the inches, right? And yes, I know that you are asking yourself, but if I did directly, like I have feet already to meters, will be the same thing, okay? So you're gonna do the same thing, but we will shorten this over here, but the process is the same, okay? So then I have a minute that is a second, 1 minute, right? I can run 65 meters, but I don't want a minute, I want second. So I know that 1 minute is 60 seconds. So now I can cut off this minute with the minute, and meter with the meter, and I'm gonna have the time. So if you multiply this by this, 12 by 1, and by 60, right? And divide by the product of those. Okay, I know that multiply by 1 would be the same number. However, I'm just trying to show the process. So that we're gonna have 1,577.75, right? And look at this. This is conversion. You don't look for this. Okay, that is conversion. You don't look this. So we have a multiplication. You look for the smallest number of significant figures, which is 2. Okay, the rest is conversion, exact numbers you don't count. So the only one that you're gonna look is the dots you have. Well, you run 65 meters in 1 minute, and I have I would walk 5,555. Here I have 4 significant figures, and here I have 2 significant figures. So I'm gonna go to the smallest one. So that will be over here. So then I can round for 16,000. So seconds. So I have 2 significant figures, right? Oh, if I want to do scientific notations, use scientific notations, you can. So remember just how to use scientific notation, okay? So then I can use 1.6 times 10 cubic seconds, okay? But still, I have 2 significant figures over here, right? So that's it. That's all. Bye for now.